Today is going to be 13-1, and we're going to take a look at inequalities and functions. So we're going to understand what function inequalities represent. So let's examine. If I said f of x equals 2x minus 1 and g of x equals 5, let's solve these let's examine these four different scenarios. So the first says, let's solve f of x equals g of x. So that literally means 2x minus 1 equals 5. So now for this scenario here, if I'm solving for it, means I should add 1 to both sides, and I get 2x equals 6, divide both sides by 2, I get x equals 3. And so this right here is going to be my answer at x equals 3. Now for this next one, it says solve where f of x is less than g of x. So that means I get the statement 2x minus 1 is less than 5. Well, for this one, if I solve for this, I get add 1 to both sides, and I get 2x is going to be less than 6. Divide both sides by 2, I get x is less than 3, which is going to be the solution set. If this was positive 3, it's going to be open circle. It's going to be everything smaller than that. Number 3, it saw f of x is greater than g of x. And so if I have this f of x is greater than g of x, now I have 2x minus 1 is greater than 5. Well, if I solve for this, if I add 1 to both sides, I get 2x is greater than 6. Divide both sides by 2, I get x is greater than 3. And so now for this x being greater than 3, the solution set, once again, I have 3, open circle, and it's going to be everything greater than that. And so this next part, it says graph y equals f of x and y equals g of x on the same set of axes and interpret your solutions from part 1 through 3. So my three things we said was f of x equals g of x. We said f of x is less than g of x. And then we said f of x is greater than g of x. So let's take a look at those. Now if I graph them, my first one we said is 2x minus 1. And g of x equals 5. So there's my g of x equals 5. And then the 2x minus 1, so it means it's going to start here, up 1 over 1, up 1 over 1, up 1 over 1. Now if you notice this, if this is my graph, where f of x equals g, that's representing where they intersect. This is saying where does this graph equal this graph, and that happens to be here, which is why we said it's where x equals 3. The next one, f of x is less than g of x, this is saying where on this graph is my function f of x smaller than g of x. And so we said that the answer was x was less than 3. We said x is less than 3. Now if you notice on our graph, where 3 was, everything less than that, this was smaller than the graph. If this was 5, this side for my function is going to be less than that 3. And so that's why we said my solution is going to be x is less than 3. Now where it says f of x is greater than g of x, that's where this function is going to be greater than 3. And so if you notice, this part, my function, going up forever, that's where it's going to be higher than my g of x. And so that's why we said the solution set there is going to be x is greater than 3. And so we're able to just be able to create these different regions just by examining what these two functions are. Now we call these inequalities, and the idea here is that when we're solving these inequalities, we're going to be using this type of analysis. So let's interpret these and formally define them. It says suppose f and g are functions. The solution to f of x equals g of x are the x values where they equal each other or where they intersect. The solution to f of x is less than g of x is the set of all x values where the graph y equals f of x is below the graph of y equals g of x. And the solution to f of x is greater than g of x is the set of x values where the graph of y equals f of x is above the graph of y equals g of x. So looking at this next example here, it says, use the graph to answer the following question, solve f of x equals g of x. Well, that's where they intersect. So they intersect here, and they intersect here. So my answers are going to be negative 1, 2, and 1, 2, but we're looking for the x values, right? So it's going to be x equals negative 1 and positive 1. Now solve where is my f of x less than my g of x. So that's going to be here and here. And so my inequality that represents that is going to be x is less than negative 1 and x is greater than 1. And then it says solve where my f of x is greater than the g of x, and that's going to be this region here. And so that's going to be between the values 1 and positive 1. I could also say x is going to be between negative 1 and positive 1. Now if you notice, because this says equal to, that's why I have these included statements here. Or that's why I used equal to statements. Because this doesn't say equal to, that's why I didn't have included statements there. So you just got to be careful in our inequalities. If it says equal to, that's referring to the open and closed circle stuff. So taking a look at this scenario here, f of x equals x plus 3 squared minus 2 and g of x equals negative 1 versus this x plus 3 squared minus 2 plus 1 is less than 0. If we're examining these two scenarios, what's going to be my f of x is less than g of x? Well, for this one, if this right here is going to be my f of x, and this right here is going to be my g of x, where my f of x is less than g of x is going to be this region here. Because right here, this is where it's going to be below my g of x. So that's going to be the answer there. But if I were to solve this, it's saying where is this function here less than 0? Well, if I simplify this, this is going to be the same thing as x plus 3 squared minus 1. Where is that less than 0? Well, this is the graph of that. And if this is my function 0 here, right, it's like this imaginary line of 0. That means that my answer, what's below it, is still going to be between negative 4 and negative 2. Now these graphs look similar, but what's the difference? And that's something to really kind of think about here. Because one thing that we're going to be doing is instead of just comparing functions, we're going to be comparing it to 0. Now the reason why we want to compare it to 0 is because if we look at a number line and 0's in the middle, we're able to perfectly divide out negative numbers from positive numbers. And that's going to be crucial, and you're going to see why that's going to be crucial in these coming lessons. But technically this statement here is going to be the better statement, because what it's doing is it's separating, and as we can take a look, it says what are my values that are less than 0, or what are my values that are negative. And so these are going to be all the values that are 0, or all the values that are going to be negative. And so that's partially why it's crucial, just because we're able to divide those numbers there. And this concludes our lesson. If you guys have any other questions, please leave them in the comments.